recorded. I just got the little notice. Okay.
I'm glad you got notified that we are recording this because
I know that.
sometimes we don't.
No, we don't. We always have to know recorded.
Could you imagine getting all the way through one of these videos and like, I never hit record?
I've done that in my classroom. Yeah, I have. I'm not going to lie. Okay. So anyway, I assume
Welcome to 3.2, which is our introduction to planning a study. We have a couple of different objectives here. The first one is like identify the type of study. And then the second one is identify appropriate generalizations and determinations based on an observational study. So what are a couple of types of studies we're going to be looking at?
well, we can do something to somebody. Like I can like give you a pill and see how it affects you, or I can just watch what you do and gather information without actually doing anything. That's the two main things we look at in this in statistics. So do I do something to you, or do I not do something to you? Just gather it as you are. And we're going to define those, but I like to Mr. Bobby eyes some things because I have to like put it in my own brain in simple terms. So we have some terms here. You need these terms. These are super important.
We're actually going to walk you through the essential knowledge just a little bit because sometimes just knowing definitions is super important. So the first thing I want to mention is that when we use the word population, we're talking about all the items of interest. So if you think back to the last video, when we survey Lakeside, our population is every single student at Lakeside and their family. Every single one of them, okay? And if we talk about the Ford F-150 problem, we talk about every single Ford F-150 currently being driven.
There's no way I'm going to be able to gather all of those Ford F-150s. I might be able to, and I really do need to figure out what everybody wants at Lakeside, and that's even going to be challenging. But there is no way you're ever going to, by the time I finish gathering the Ford F-150s, some of them will be in accidents and won't be on the road anymore. So the population is actually fluid in that case. And we want to understand and realize we're talking about this in terms of words that may lead you to believe human beings, but it's not necessarily. It might be an inanimate object.
Right.
So since we sometimes
say
I was going to do the next one. I think the population is all of them, okay? And that's everything in existence. But we very rarely can get all of them. So what we do is we take a sample. Instead of surveying every American who's going to vote in the next election, they get on the phone and they call a subset of the Americans. So they may call, and they may just do this for Arkansas. They want the Democrat Gazette may want to know how the state of Arkansas is going to vote. So they'll hire somebody, and that person will call people from different parts of the state and gather a sample. Won't be able to talk to every American, and so they just survey maybe 1,000 people to get an idea.
Right. And one thing that we want to make sure that we're careful of about our sample is that it does represent the population of what you're looking at. So let's say I am surveying everybody in Arkansas. And let's say after I collect my sample, I realize that the majority of my sample are over the age of 60 because I called during working hours and all I got were retired people. Does that sample represent the population? And that's going to be such an important thing to us because we don't want to make decisions about a population off of a poorly represented sample.
And that's what the essential knowledge in the last one was about chance. We want everybody to have a fair chance to be, or everything to be represented in our survey.
Right.
Or sample.
Right. So the first thing we're going to be looking at in this module are observational studies. So Mr. Bobby said there are times that we apply something to our subjects, like a pill or something like that. And then there are times we just observe, make note, and make decisions based off what we observed. Those are called observational studies. So when we don't apply any kind of treatment to something, all we do is look and see what happened. That's called an observational study, okay? And so when investigators examine the data for a sample set of individuals, that's called retrospective. When we follow a sample of individuals into the future collecting data, that's called prospective. And no matter what we're doing, we're trying to investigate that population to answer some question. So, go ahead.
I was just following behind you and underlining words for them. And then do you want me to talk about experiment or?
So let me stop for just a second. So we used the word survey in the last slide when we talked about, and this is often used when we want to know something about a group of people, we send out a survey. So that word survey, a sample survey, actually means we assume we're not going to get everybody, right? We assume we're not going to get the entire population. There's another word for we do get the entire population. We're going to talk about that in a minute.
And then on the counter to an observational study and a treatment is when I do something. So like I may be watering these plants every third day and then watering a different set of plants every fourth day and then another set like every 2 weeks. And I want to see if how often I water the plant has an impact on how tall they grow. That's an experiment. That's when I'm doing something and comparing an outside influence. Okay. And those are, I'm going to do some treatment. We call it a treatment, but that doesn't necessarily mean me giving you a pill. I know your language may influence you, what you're thinking, but the treatment may be, I decide to feed this dog brand A of dog food and this dog brand B of dog food. And I'm comparing their health after eating 2 different types of dog food. Okay. So that's a treatment. That's not me applying a medical treatment. Don't confuse it with that word.
Yes. Very true. Very true. Very true. And sometimes people will be doing something in your observation. But you didn't do anything to impact that. Right. So that's important too. It's just something that you are applying.
Yeah.
Okay, so we talked a little bit about our sample being selected in order to represent the population. We're going to use this word random, and we're going to use it over and over and over and over because it is obscenely important in the context of collecting data. Right, Mr. Bobby?
Yeah, I'm still circling it.
Whoa.
I really wanted to circle that word. Randomly is, and that's critical. The only way we can truly trust our experiments. Remember we talked about truth is instead of me just standing at the entrance to Walmart surveying all the people who come to Walmart, if I do that, I'm only going to get a certain type of person. I'm going to leave it at that. But if I stand outside of Dillard's, I might get a different type of person. Okay. Okay.
Oh my God. Okay.
I need to make sure that I'm getting the clientele of all kinds of different stores at the same time, if that makes sense. Okay.
Yeah.
Go ahead.
One more important thing on this slide is when we're looking at an observational study, we are not looking at causal relationships. We are simply saying there's something strange here, right? Mm-hmm. So we're not saying I observed this, and so now I've noticed this thing, so this caused this. We never want to say that based on an observational study.
Okay. So we can't say that, we just saw it and it is what it is. Okay.
Yeah.
Gosh, my writing is terrible today. I am sorry. So let's move on.
Okay. Okay. So a little visual here of what's going on. Let's say we have a population. So let's say this is every student at Lakeside High School. And what might I want to know about that population, Mr. Bobby?
If they think Crocs are cool.
Okay. So let's say I want to know if Lakeside students think Crocs are cool. I don't want to go to every single student at Lakeside and ask them. Or even if I did try to do that, they're not all going to respond. So what I'm going to do is I'm going to pull I should back up and say, if I could ask every single person and every single person responded, I will have collected a census. Now, this is so interesting because we've talked a lot about the census, right? Mm-hmm. When we talk about the census, Mr. Bobby, did we ask every single person?
They tried
to.
They tried. And I don't know if you've seen the ads or even heard, but the United States government hires people to go literally knocking on doors because there are people who do not want to answer the census for whatever political, religious, philosophical reasons. But we need to know as a country how many people are living here because there's a lot of things that are attached to it, funding and allocation of seats in Congress and such. But it's impossible. Even the government, and by the time they finish it, more people are born and some people will have died.
Yeah.
So from the time that they start trying to count to the time that they finish, it's such a long period of time that the population has changed. So they really can't do it. Okay. It's actually it's a very badly named thing. It's constitutionally mandated. We have to do it. But it's not statistically a census because they actually end up just doing what we do anyway to figure the answer out.
Right. That's right. So a census is if you could collect it on everybody. So if I really could ask every single high school student at Lakeside if they liked Crocs, collect that data, that would be me collecting a census on Crocs.
And by the time you did that, maybe a student would have moved away and another student would have entered. Right.
And so it's hard to measure everyone. And so what we want to do is we want to think about, okay, I can't measure everyone. So let me measure a few people. Let me ask a few people. Because if I could get a few people who do a good job representing my population, I can begin making inferences about that population. What does inferences mean, Mr.
Bobby? You're going to try to assume if that group is representative, what they tell you is a reflection of what the larger group is.
Right. And here is where random becomes super duper 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 important. Because if it's not random, then how I pick my sample could create bias within my data. And my inferences could now be totally wrong. Okay?
So you put it in there.
So my sample is just this little group from the population. Some of the stuff that we use in this module is going to be from a website called Skew the Script. I'll try to always put it down here in the right-hand corner when I'm using their content. So if you're seeing this and wondering why it's down there, it's because we're borrowing content because it's so well done, okay? All right, so we talked about the fact that their sample is just a subset of individuals from a population. Now, I know what you're thinking. You're thinking a sample has to be humans because in my model here, it's humans. Guys, that can't be further from the truth, okay? So I want to show you one of the more famous statistics problems from the World War II era. So there was this statistician, his name was Abraham Wald, and he worked for the Allied Forces Statistical Research Group. And he collected some pretty interesting data. So we're going to watch this short video, and then we're going to talk a little bit about it. Wow, that was crazy.
Abraham Wald was a Hungarian Jew born in the Austro-Hungarian Empire in 1902. Anti-Semitic attitudes were common in the region, but not necessarily worse than anywhere else in Europe. And so as a result, Wald was able to live a relatively comfortable life, even obtaining a PhD in mathematics from the University of Vienna. However, by the early 1930s, Austria's economy was on the verge of collapse. This, combined with Wald's Jewish heritage, made it virtually impossible to find work in any university. Wald was eventually able to use his contacts at the University of Vienna to create a new position for him at the Austrian Institute for Economic Research, and so he eventually was able to make a way for himself. However, this was complicated in 1938 when Nazi Germany annexed Austria and banned Jews from working in universities as professors. Wald, fearful of Nazi occupation, began looking for a way to get his family out of the country. He was able to and received a grant from the Coles Commission for Research in Economics and bounced around the United States until 1941 when the United States joined World War II. Wald was immediately recruited, moved to New York City, and assigned to the now famous Statistical Research Group, SRG, out of Columbia University. The most famous problem that the SRG worked on was the issue of how to armor planes. Planes with too little armor are easy to shoot out of the sky. Planes with too much armor are difficult to maneuver and cost incredible amounts of fuel. So what was the issue for the SRG? Figure out where to put the armor on the plane where you get the biggest bang for your buck. The problem with many principles in statistics is that having the right data isn't enough. You have to understand the context and how to interpret the data. And statistical analysis can be counterintuitive. After months of bad analysis by commanders in the field, Wald wrote the now famous sentence in his report, quote, "Gentlemen, you need to put more armor plate where the holes aren't, because that's where the holes were on the planes that didn't return." That sentence probably saved 100,000 lives and was a major contributor to the war effort in both theaters. American planes were shot down so infrequently in the latter half of the war that many of those same planes were used in both the Korean and Vietnam Wars a decade later. Robert McNamara, the military's liaison to these analysis groups, said of the SRG, quote, "We won the war with individual bravery, statistical analysis, and 2 really big bombs." Now, why did Wald agree to work for the SRG? Wald's personal motivations are a little complicated. It's easy to say that his Jewish heritage meant that he had a special stake in the war, like fellow mathematicians Albert Einstein and Niels Bohr. But the problem is that it's not entirely clear what the American government, much less the American public, would have known about Nazi war crimes early on in the war. We knew about the discrimination. European Jews like Wald had experienced it firsthand, but this was not entirely unusual. Europe had a long history of discrimination. Even in the United States, when working for the SRG, Wald was not allowed to see classified material having been labeled an, quote, "enemy alien," an official designation of the U.S. military. This was absolutely ridiculous, and that a great deal of the classified material Wald wasn't allowed to see, he was himself producing. He was producing classified work that he was not allowed to look at. There was a running joke in the SRG that when Wald finished writing a report, a secretary had to immediately take it from him in order to save him from a court-martial. We knew that the Jews were being housed in concentration camps, but this did not immediately raise alarm bells either. Interning potentially treasonous populations was common practice at the time, demonstrated by the United States' infamous internment of Japanese Americans. While the upper echelon of military intelligence might have known what was happening, the average soldier would not have known until 1944, when Americans began liberating concentration camps. Most people in the general public didn't know until 1947, 2 years after the war, when the Diary of Anne Frank was published. How aware the United States was of Nazi war crimes while they were being enacted is a major historical controversy. For Wald and his Jewish contemporaries, none of the Nazi war crimes would have been a surprise to any of them. However, the opportunity to do meaningful work as a patriot of his new home was probably Abraham Wald's primary motivation. Tragically, at the age of 48, Wald and his wife died in 1950 when their plane crashed in the Nilgiri Mountains after attending a conference in Calcutta, India.
So, Mr. Bobby, what was the question that we wanted to answer using statistics?
Well, we want to
Abraham
figure.
Wald was a Hungarian Jew.
I'm sorry.
Okay. Can you go back to the pictures of the planes?
Born in the Austro-Hungarian.
So the next slide.
I think so. Yeah.
If I can, yeah.
We can put armor on the planes, and I'm not going to try to say I'm anywhere near war. I mean, I was in the military, but I wasn't involved in any kind of thing like this. But we want to be able to protect the planes, but if we put too much armor on them, they can't move. And that's the same thing with a soldier or with any. You can put bulletproof vests on somebody and cover every inch of them, but then they can't actually fight. Okay, so we wanted to figure out where to put armor on the planes to make them survival being shot. And
so what's the population for this? So we've got a question. What's the population?
All of the planes.
Okay.
From World War II.
Okay. So what's our sample?
the ones that survived. He was the problem. Because what happens when a plane gets shot?
It-
Yeah, if it's shot down, can you see the bullet holes in a plane that has exploded?
Definitely not.
The plane has exploded and you can't tell where it was shot. So he had to work backwards.
He did. So because there are more brilliant people than I, we're going to jump over to a Harvard Think Big. And I know this is a lot of extra video watching within your video watching, but I think that both of these are worthy to watch in this case.
So Abraham Wald was a famous statistician, and during World War II, too many British bombers were being shot down by the Nazis. So he was consulting with them about trying to figure out where to put more armor. You know, they want to put more armor, but the armor is heavy and expensive. They can't just put armor everywhere. So where do you put the armor? Okay, so I drew some airplanes here. These don't really look like bombers, but that's okay. So here's some airplanes, and I just drew some bullet holes. There's one. Sorry, I didn't have a warning that there'd be graphic violence here, so hopefully no one is too squeamish. There's another one, another one. Bam, 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 bam. So these are I just made up some bullet holes on these planes, and these are the planes that they get to observe. Okay. Just as an example, and so they brought in Wald to ask, where should they be putting more armor? Well, the obvious thing to do is look at where all the planes are sustaining heavy damage and armor those regions more. However, Wald said to do the exact opposite. Look for the parts of the planes where there's very little or no damage on the planes that came back. The reason is, so for this example, I protected the nose on all of these planes. And so what's really going on here? Well, what we're really interested in is the planes that we didn't see. Those are the planes that didn't come back. The ones that you actually get to see are the planes that actually survived well enough to return. So there's some statistical thinking in there. How do you learn about the planes you don't get to see? And that requires some statistical assumptions and statistical thinking about what do you do about the missing data, right? So maybe what if it looks like this? That this plane, we didn't get to see it because that's like the Achilles heel or the Achilles nose of the plane, and maybe there's like a whole army of these like Rudolph the Red-Nosed aircraft that we don't get to see any of them because they all died and we only saw the other ones. So that's where you put the armor. So that was the idea. It's a pretty simple idea in retrospect, but easy to miss if you're not thinking statistically.
So the guy that we just listened to is he's pretty famous at Harvard for
Abraham Wald.
We're not trying to listen to that again. For being one of their big statistics professors, and this is a problem that a lot of statisticians kind of sit on because how obvious it is. But the fact that it took so long for us to say, like, oh, our sample is not what we think it is.
Right.
So, Mr. Bobby, where are we putting that extra armor?
Well, according to him, we were going to put it on the nose because none of these planes got shot there. So if all of our data, so this is the ones that survived. So we're assuming since none of them got shot in the nose, that if you get shot in the nose, you go down. And in this case, it might make sense because where does the pilot sit?
Right. So really, I showed you a very short little snippet of this video. The whole video is about 14 minutes long. It's down here at the bottom. This slide is in Classroom. You can always go look. I think it's worthy of a watch if you have time to watch the entire 15-minute or 14-minute video about his statistical thinking. Okay, so what we just looked at, we didn't talk to humans, we looked at planes. Is that an experiment? Is what Wald did an experiment?
Well, the question you need to ask yourself, did he apply a treatment? Did he do something to the planes?
Nope.
Okay, so if he had put armor on some planes and not armor on the other, then it would have been an experiment. But
That's right.
we just gathered the data.
That's right. So once he makes the decision, like, well, the planes that came home, none of them had anything wrong with the nose, so the nose is the issue. The next step, let's do an experiment. Let's see if he's right. Let's apply the armor to the nose of the planes and see if they come home. And they did. In the first video, you heard that not only did they come home, but they were used again a decade later.
In successive wars, yeah, they were able to be used in future wars, which, whatever, but still, that's success in that experiment. So
That's right. So that's it. We have talked about war and Nazis and terrible things. So I'm hugging you from afar because those were hard topics to look at. You've got 3 Khan Academies to go with this assignment. So we hope you enjoyed this video. We hope you learned a little something, and we will see you in 3.3. Bye.
Bye-bye.